In this lesson, we'll talk about how to solve problems involving collisions. Here's a collision between two little football players. So we have the kickoff. The guy gets it. He starts his run back. Here comes the defense. Oh, that's got to hurt. The main idea with collision problems is to know the initial conditions. If you know the mass and the velocity before the collision of each person, then we could find out, what was the velocity of them after the collision. And we're going to use a prime notation, which means after. So it's kind of like final and initial, except that we're going to have subscripts we're going to call maybe the red kid M2. So we're going to have V2 and M1 and V1. So it's going to be confusing down there. And plus, it's not like the very initial and final velocities, but right before and right after the collision is what we're looking at. In this collision, the kids are going to put forces on each other. And with Newton's third law, we know that the force on the red guy is going to be equal, but opposite to the force on the purple guy. And the time that the red guy is in contact with the purple has to be equal with the time that the purple is in contact with the red. You can't be touching someone for more time than they're touching you. So what we're going to do is we're just going to multiply these times by the forces. So what we get is the force of the red guy times the time of the red guy is equal but opposite to the force of the purple guy times the time of the purple guy. And the quantity of force times time is impulse. And for impulse, we use the variable j. So what this says is the impulse of the red is equal to the impulse on the purple guy. And impulse results in a change in momentum. So the change in the momentum of the red is equal but opposite to the change in momentum of the purple. Change in anything is final minus initial. In this case, we use after minus before. So p prime minus p equals, and then we have a minus p prime minus p. And I'm going to distribute the negative sign. The left-hand side stays the same. P prime minus p equals, if I distribute this negative sign, that gives me minus p prime. And then I distribute this to the minus p plus p. And now we need to get the befores and the afters on the same side. So over here I have a red p prime. On the right-hand side I have a negative purple p prime. So if I add purple p prime to both sides, that would go way over there, and I would get that over here. And then on the right I have a momentum before of the purple, and on the left I have momentum before with a minus. So if I add that red momentum to the left side, it goes away, and I have red momentum here. And what this really results in is that the momentum after the collision is equal to the momentum before the collision. Or overall, momentum is conserved throughout the collision. So let's take a look at an example problem. We have a football player that's going to have a collision with a yak. And we want to know what is the velocity after the collision. Well, in all collisions, we know that momentum is conserved, so I'm going to start with momentum before equals momentum after. I have two objects. So I know that I have the momentum of the first object plus the momentum of the second object. That's my momentum before the collision. Is momentum of the first after plus momentum of the second after. Well, momentum is mass times velocity. So this is m1 v1 is my momentum first. m2 v2 is my momentum second object. Then I have m1 v1 prime. That's momentum of the first object after the collision. m2 v2 prime, momentum of the second object after the collision. What I want to talk about is after. If they stick together, then v1 prime is equal to v2 prime, and we're just going to call that v prime. So when we look at the right-hand side, mass 1, that's the mass of the football player, is 125 v prime. Mass 2 is the mass of the yak, that's 220 v prime. And on the left-hand side, I know everything. Mass of the football player is 125 and traveling 8, plus the mass of the yak, 220 times 3. But remember, momentum is a vector. The yak is going the opposite direction of the football player, so we have to have an opposite sign, -3. So this results in 1,000 minus 660 equals, and then on the right-hand side, we have 125 v prime and 220 v prime, which is 345 v prime. So our math here, 1,000 minus 600 is 340 equals 345 v prime. So we divide both sides by 345, and we get v prime is just about 1 meter per second. Since that value is positive, which is the way of the football player, it would end up in the right direction after this is done. Anytime there's a collision, you have conservation of momentum. And in golf, when you hit the ball with the club, there's a collision with a large impulse of force times a short amount of time when the ball's hit. And the Callaway Golf Company understood this concept in making their Big Bertha driver, and even went with the advertising campaign of "you can't argue with physics" as far as the collisions that occur between their golf clubs and the golf balls. So in summary, remember that momentum is conserved in all collisions. So momentum before equals momentum after. Remember that momentum is equal to mass times velocity. So the idea is however many objects you have moving before, you have to do mass times velocity for each object. And then take the mass of each object and its velocity after the collision. Remember that momentum, like velocity, is a vector. Pay attention. If the objects are going in opposite directions, then their velocities must have an opposite sign. If the objects stick together, we will say that they will have the same final velocity because they're moving together, and we replace v1 and v2 prime with just v prime. At this point, when you look through, you'll know mass, you'll know velocity, so you'll only have one unknown, which will be v prime. There will be cases where maybe you know the velocity after the collision, and you know the masses of all of them, and maybe a velocity before is what you're trying to find out. But the main overall concept with the collisions, remember, is that momentum is conserved, and from that, you can set up to solve these problems. Please give me some feedback on this lesson, and hopefully it was helpful.